Hello everyone. So we are starting this new series of where we tackle the new areas of question and concept. So let's start the video. So here is the question called sort colors. It is given that an array of zeros, ones and twos. You might have seen this type of pattern of the question beforehand. I will also provide the problem link below. Please refer it and try to solve it by yourself. So we are given an array that has elements that are 0, 1 and 2 provided, and we have to sort this array. So the input is like you can see the array is 2 0 2 1 1 0, and corresponding to the input we have to generate the output as 0 0 1 1 2 2. So first we focus on what it is given and then we solve the problem. It says only element are 0 1 and 2. By observing the array we have to sort that and return it. So the approach should be, if we create a function, think about it and solve it. So let's discuss. If we create a function and function name like sort array for suppose, and in this we can give the array of size, let's say n, and input of n elements likewise, and then sort it in ascending order. So it can be solved. So the array is 0 2 1 2 and 0, and we have to sort it in build function to just sort the array, and the time complexity of this problem is big O of n log n. But in this problem, we are thinking, is this an optimal approach? No, it is not an optimal approach. So what we can do? So we are missing out the one thing, that is we can clearly observe in this array that the individual elements are 0, 1 and 2. So by this information, we further think about it and we could reduce the time complexity of this problem. Let's say I know the count. So how many zeros and ones are there in the array and how many twos are there in this array? So if I know the count, it shows in the array, it clearly visible that we are refilling the array again. For suppose the steps would be, first of all we take the number of zeros and fill it first. Then we move on to the number of ones that are existing in the array. Then third, we will similarly fill the number of twos. And we basically need the information as the fact as it could be if we ask for a count. So we can clearly say that we will implement a counting sort. For that, the count is of 0 and we will see the count of 1 and the count of twos. So the array is 0 2 1 2 0. Array will be 0 2 1 2 0. So we can say that the count of 0 is 2, the count of 1 is 1, and the count of 2 is 2. And we will create a loop and just push the element into the newly created array. And after that, what we will do is, after inserting, this is the initial array of 0 2 1 2 0, and after inserting what we will see is it will be same but the count will be different. What I mean to say is that the element will be same but the count we are supposed to do is, for let's say we will see for 0, so it will be 2, for 1 it will be 1, and for 2 it will be again 2. It is for 0, it is for 1, and it is for 2 respectively. So the time complexity of this approach will be, as we have broken this into the smaller bits, so this will be big O of n plus big O of n, that will be big O of 2n. That will be the time complexity of this approach. And like if we think of the further optimization, more optimal approach, there is an algorithm known as the Dutch national flag algorithm. We can say that this algorithm can also be referred somewhat similar to our most famous two-pointer approach. What is this? We will discuss the two-pointer approach. So in this algorithm, you need to consider the pointer approach, but previously I was discussing about the two-pointer approach. It was a pointer approach, but rather than it is a two-pointer, it will be using a three-pointer approach. The one would be in a lower pointer and other would be the mid pointer, while the other one, that is the higher pointer. Let's say this is a given array and we are given as 0 to 1 to 0. So we will mark it as low here and mid here, and the higher will be here. So what I'm trying to tell you is the one which is at the lower, that is 0, and the other one which is a mid pointer, that is again a 0, while the other one at the higher end is also a 0. So we have to solve this question by using three pointer. But for now, I am not using this approach. We will discuss it again in some another video. We are using the hash map approach. First of all, it will count, or it will store the count on the map, that is zeros, ones, and twos. Then secondly, the maps which are being valued as 0, the maps which are valued as 0 will be iterated, and we will keep the track of the updated map, and we will increment the count as count plus plus. The counter will always update the map, and whenever there will be a repetitive element, for suppose a 0 comes, or a 1 or a 2, it will always search for 0, and next it will again search for 0, and it will then swap its place by interchangeably the element around the array. So this will be the whole approach. Then the third step would be again counting 0, 1 and 2 and filling it. So it will sort. And another short approach is also coming in my mind. That is, what if it is a count sort algorithm? No. So we can easily sort from, let's say, using a sort arr dot begin to arr dot end, and we will usually say that the whole array is sorted. So let's move on to the code. The code is such a way that we can see count occurrence of 0, 1 and 2 is filled in the array. Then as we have discussed, checks whether the value of counts is present in the key or not. Then the number of key that are being initialized, that have been returned as counter is equals to counter plus the value that has been given. So if we submit this code, it beats 7.39%. So yeah.